Okay, so I wanted to make a screencast of this Leetcode biweekly contest, but I forgot the contest tha. So let's just dive into the editorial. Okay, um, questions were kind of easy. Like, I mean, let's see, I was able to do all four. Okay, so there were 1870 submissions. Yeah, so you can see it was kind of easy. So let's look at the first problem. Um, okay, so the first one states that we're given a string s. The score of a string is defined as the sum of absolute difference between the ASCII values of adjacent characters. So if you see, this is very simple. Like this could be A, B, C, and you just have to find the difference between these two values and these two values. This is one plus one, so this is two. A simple loop for loop would be able to do this. So it's just like um, I is less than s dot size. Actually, start from one and not s dot size minus one because sometimes it will give you a wrong answer. And over here you declare a answer is equals to 0 and then answer plus would be equals to s of I minus s of I minus 1, and then you just return answer and yeah. Mm, what? Okay, your first problem was very easy. uh, Wait, what? Oh, sorry. Yeah, it was the absolute. I forgot absolute. Yeah, first was very easy. Now coming on to the second problem. So in the second problem, it stated that you have to find like points that actually you just have to find like you're given some points xi comma yi x comma y, and now you need to find like you need to fit all of them into some rectangles. All right, but the thing is that the width of this rectangle must be less than equals to w, and it is not given anything about y. So that means you can assume y to be some very large value. So that difference between and it's not like they must lie. All the points must lie on the corner. All the points could lie here, here, and like this as well. Although it would be better to start from this point and end till this point. If it is just three, and then this could come in the middle. So implementation was it was very easy once you just realize the fact that y does not matter. So y could be any value, and if you just want to fit them into some minimum sort of rectangles, all you have to do is just sort these values. Like you just sort these values by x. So over here it was 2 1 1 0 1 4 1 8 or so on, and then this is just like 1 0 1 4 1 8. After that 2 1, and then 3 5, and then finally 4 6. So and the difference is 1. So 1 could be here, and then 2 could be here, right? We cannot include 3, so we start from a new rectangle from 3 and go till 4. So the answer here is 2. Alright. And then in this case 0 1 2. This is already sorted, so and W is 2, so 2 could come, and then 0 would come, and then 3 would come, and then up till 5 would come, and then for 6 we need a new rectangle as it is given. So implementation wise I just sorted all of these points and kept a previous denotes the width of the denotes the leftmost x quadrant of the rectangle. Then I iterate it from 1 till n, and previous equals to points of I comma 0 if previous equals to minus 1, which will only happen in one case. Otherwise, uh, if the width of the rectangle, which is x minus previous, is more than w, then I need to set my previous as x and form a new rectangle here. So that is all that I have done. And yeah, okay. Moving on to the third problem. So this was actually a pretty interesting problem. Basically, you are given some 0, 1, 2, and also you are given some disappearing values. So from you have to start from node 0 and you have to reach till all the other nodes, such that the distance between from 0 till this node should be minimum. So as you can see, this is normal Dijkstra's. Like you start from 0, and every time you it happens that you can reach a node from the previous node by adding some lesser value. You will update that to, like, let's say distance of node is like greater than distance of node let's say parent, which is the node that I'm coming from, and plus this edge weight. Then you will just update this to this, right? Now what is the gist here is that we have some disappearing of I values, which means that after some point of time this node will disappear. So I need to keep track of how many jumps have I taken. Alright. No, not jumps, because each traveling edge will cost me some time, no? So if that time ever exceeds the disappear of I value, then I won't be able to travel to that node and I just have to update it to minus 1. Alright. So yeah, let me explain it to you via code. So here I have kept a adjacency matrix, and then over here I have considered an adjacency list, and now this is just UV and W just created an adjacency list. Now I use a priority queue to store the now in the priority queue I will first add the distance and then the node itself. Vector of answer comma minus 1, this is just the answer vector that I'm going to return, and then a visited value. The thing is that the constraints in this problem are a bit tight. This is n is 5 to 10 to the power 4, and then log n. So let's calculate. So this is 5 to 10 to the power 4, and log n would be some log 2 base 5 to 10 to the power 31. So that would be around 20 or 30. So this is reaching almost 10 to the power 7, right? So if I'm visiting some nodes again and again, let's say more number of times, because the extras will take O of e plus v log e, right? So in this case, it can exceed the constraints. So I need to make sure that I'm not visiting the same node again and again. All right. So you push pq dot push equals 0, comma 0, which is the starting node and the distance itself. After that, answer of 0 is equals to 0 because you start from here, right? Then this is just Dijkstra's algorithm. Okay. This is to reduce the complexity. And now over here, you can see answer of neighbor is equals to minus 1. That means this is the first time that I'm encountering it. Or it is like the new weight, which is the parent weight plus the edge weight, is less than the answer of neighbor dot first, right? In that case, you just have to update this value to new weight and just return the answer. Okay. Okay. This was a pretty nice problem. Uh, Let me try to explain it to you in simpler terms first. All right. Okay. So if you don't have any knowledge about segment tree, then you might need to study that first before you see my solution, because I've used a segment tree here. Although it is possible to do it using a monotonic stack or something, but I haven't tried that approach. Okay, so in this question, basically, you need to make sure that the first and the last elements of a subarray are the maximum elements of a subarray. All right. Like let's say you have 1, 4, 3, 3 and 2, right? So if you take 1 comma 1, then 1 is the maximum over here, 4 comma 4, 1 is 3. In this case, if you take 2 comma 3, then 3 is the maximum element in this subarray, so the answer is plus 1. Alright. So answer is 4 plus, how many elements are there? 1, 2, 3, 4, 5. So 5 plus 1 is equals to 6. And okay, I think so. Let's me change the question a bit. What if the question was you need to find like the number of subarrays such that the element in that subarray is equals to the maximum element of that subarray, right? So if you see, so for that the first and the last element are equals to the maximum element of the whole array. So in this case, it would be this array, and then you would have this array, and then this array. So that is three, and then this array, this array. So five, and then this array, six. All right. Yeah, so 6. All right. And uh, once you understand the concept, so if I just have to check for the maximum element of the whole array, this is 3, and then this is 2, and then this is 4, and this is 2, and then 4. So how many times is the maximum element coming? So this is 1, 2, and 3. So now total number of subarrays would be 1, 2, 3, 4, 5, 6. So that is equals to the count into count plus 1 divided by 2. Alright. Now, once you understand that for the whole subarray and the count, alright, now it is easy to understand for the entire array. Like, all you have to do is maintain a map of int comma vector of int. This will give me all the places where this particular index is coming. Alright. And then for each consecutive, I could check if this is actually the maximum element in this subarray. Let's say this is 3, 3, 3, 5, 6, some 8, 9, right? And then and check the element is 2. And then between 3 and 5, 3 is coming. So obviously I cannot take this subarray, right? So I move forward. Can I take this subarray? Uh, if yes, then count plus plus. Count is now 2. Total subarrays would be 1, 2, and 3. If I can take this number as well, so the count would be 3. So and answer plus would be 6. And how do you check that between this range, this particular element is the maximum? That is done by a segment tree. Alright. Yeah. So that was my approach. This is actually standard template borrowed for constructing a segment tree. Basically, I just have to change the merge function every time I'm creating a new segment tree. By default, it is as sum, and I can change it to max, min, or any other element. Alright. I'm not going to explain this segment tree because yeah, I'm not very good at explaining segment tree. It is a very hard concept. Okay. Now let's come here. So this is to uh, actually I have initialized error of I as my public array when I'm constructing the tree. So I need those values which have to be inserted in the array of I. Okay. This is to build the segment tree, and now in this here I'm storing map of 2 is equals to some indices, right? And then this is the final answer variable. And then I'm just iterating through all the values of the segment tree and checking if it is possible if between L and F, which is the last and the first value, if in this range my particular element is the maximum element, that means I can take this subarray, right? So I just indicate the count. Otherwise, I have answer plus equals to sum of count, which is this. So that means up till these many indices I can do it, right? Yeah. So that's it. And then answer plus equals to sum of count. Okay, I think I'm done with the editorial. Ask doubts in the comments if you have.